So, hello guys, my name is Miłosz and today I'd like to talk to you about monads. So let me start with a question. How many of you have heard about monads? Okay, that's more than I expected. So how about, who can say that they understand monads? One hand, two hands, okay. Yeah, so monads have kind of bad reputation in programming. They are element of functional programming, which is usually people think that it's very complicated and very abstract. And it's kind of true. For me, it took some time to understand monads, and it was the first time I heard them during my studies. I didn't get them. Then after a few months, I started to understand them, and then finally I understood them when I used them at work, when I used them to build some real stuff. But why should you spend half an hour listening about monads? I think it's a fascinating concept. In front-end, functional programming is getting more and more popular, and it's now everywhere. It's in Angular, it's in React, and it's in RxJS, which is a functional reactive framework. And understanding monads can help you have deeper understanding of many different concepts in functional programming. So that's why I'd like to tell you about it. So, what is a monad? Monad is just a monoid in a category of endofunctors. Easy, right? So, yeah, not really. Well, monads are part of a branch of mathematics called category theory. And this is the formal definition of monads. And to understand this definition, you have to spend like a few years studying mathematics and category theory. So it will not be very useful for us, and we'll not focus on it. My opinion is that you don't have to understand this formal definition to use monads. It's much better to learn by example and to get some intuition about monads. So that's what I'm going to do during this talk. Okay, so let's start with from the beginning. Let's start from a code sample that we are going to look at and modify. So we have some data structure. It describes an employee. So employee has a name, ID, and it can have a supervisor. So it's an optional supervisor ID. And by the way, I'm using TypeScript here. TypeScript doesn't have anything to do with monads. You can use monads in JavaScript, that's fine, but it will be just easier to explain with TypeScript. So just to visualize, we have some example hierarchy of employees modeled using this data structure. Then we create a class employee repository, and it has the get method, which we can give it an ID, and it finds an employee with that ID. So let's say we'd like to write a function that, given employee ID, returns its name. It's a pretty simple function, but we have to be careful about one thing. We have to be careful that the employee with ID given to this function can be non-existent. It cannot be in the repository. So we have to have this if statement that checks if the result of repository.get is undefined. Let's make it more complex. Let's say we want to get employee supervisor. So now we have to do additional check, because employee.supervisor ID can also be undefined. And let's get deeper. Now we want to get employee supervisor's name. Well, it doesn't sound very unrealistic. I can imagine having to write such function in a real-world application. So now we have two levels of nesting and 3 if checks for undefined, because the supervisor ID of that employee can be an ID that is not in the repository. And finally, the ID parameter for this function can also be undefined or null or anything. So we should also check that, right? So what we ended up with is spaghetti code. This function is completely unreadable, it's hard to maintain, and it obfuscates our real intention. Our real intention isn't clear here. It's all about this checking for undefined. It's about checking for empty results, and it's not about getting employee supervisor name. So how can we fix this? We'll introduce a type. We'll call it option. So we'll start with a very simple definition. Option is a generic interface. So it's like a wrapper around a value, a simple value, and it has the get or else method. So option represents something that either is available or is not available. And it has get or else method, which will get us the nested value if it is available, or it will give us the default value if it's not available. So we create some implementations of this option type. We have some to represent the situation where option has a value, and we have none to represent a situation when the option has no value. So just to visualize it, it's a very simple hierarchy. We have the option interface and two classes, some and none. So now, having this type, we can change our classes, our functions slightly. In the employee interface, we now explicitly can say that supervisor ID is optional, right? Before we use the question mark in TypeScript, now we change it to option of number. It's no longer a number, it's option of number, because the employee can have a supervisor, it can have no supervisor. Then we can also update the repository, because the get method can return a proper result, or it can return an empty result if we give it a bad ID, an ID that doesn't exist in this repository. So that's already some improvement, because we are more explicit about what we return from this function. But we need one more thing to do some work. We will add an operation to this option type, and we'll call it map. So I guess most of you know map on arrays, right? Who knows map on arrays? Okay, a lot of hands. So what map on arrays does, it takes a function and applies it on every element of the array. And if the array is empty, it just returns an empty array. Map on option is exactly the same. It takes a function and applies it on the value if it's there. But if it's not there, it just leaves an empty option. So as simple as that. Yeah, the implementation is very straightforward. So for some, we just take this project function and apply it on this .value. And for none, we simply return a new empty option, a new none. Okay, so you remember this function, right? We can now reduce it to a single line, to one-liner. We call repository.get, and it gives us an option of ID of employee. And on option, we can call map, which transforms this employee nested in the option and gives us its name. So the result of this function is option of string. So just to make clear what map does, let's say we have a function that works on apples and it can transform them to oranges. But what I have is apple in a box. So my function f won't work on this apple on the box. But if I apply map on this function, I will get a new function that works on apples in boxes and changes them to oranges in boxes. Okay, so that helped, but we need something more. Let's say we want to do the same trick in this situation, the getEmployeeSupervisor function. Now, if we just used map on the option returned from repository.get, we would get an option of number, because this returns an option, but this also returns an option. And we don't want an option of option, because it's difficult to work with. We can't really do anything later with it. We have to unwrap the option of option to just have option. In other words, we want to flatten it. So that's why we need flat map. What flat map does, it takes a function, just like map, applies it on the nested value inside option, and if we get an option of option, it flattens it to a single option. So we extend our option interface to have flat map, and the apple oranges metaphor would be that now we have a function that can change an apple to an orange in a box, but we just have an apple in a box. So if we call flat map on our new function, on our old function, we'll get a new function that can change apples in boxes to oranges in boxes. So now it can work with the apple in the box that I have, so I can use it. So now comes the cool part, because you remember this spaghetti example. What we can now rewrite it to this. And what happened here? We eliminated all checks for undefined, all checking for empty results. What's left is just the pure essence of what this function is about, because this function is about getting employee supervisor name, and that's exactly what we do. We get, then we get supervisor ID, then we get the supervisor by this ID, and finally we get its name. So we rewrote this ugly piece of code as a series of anonymous functions passed to flat map and map. We have to use flat map here because all these things return options, but supervisor.name returns a string. So that's why it's fine to just use a map. Okay, that was the first part, the first scenario. Let's now make it slightly more useful. We are able to handle empty results with option. But usually when the result is empty, it means that something went wrong. So it would be nice to return some sort of error message describing what exactly went wrong, or to just pass some additional information. So let's adjust our interface. Now employee.supervisorID returns a result. Result is a new type, which I will not show here. But let's say it represents a result of some operation. And the result can be successful, in which case it will hold a number, or it can be a failure, in which case it will hold a string with the error message. So now we can also change our repository. The get method also returns a result. And in the successful case, it returns an employee. In the wrong case, in the bad case, it returns a string with error message. And here we can see how we can return these different cases. We just do new success of result, in which case we'll get the employee, or new failure, in which case we will get the error message. So I won't show the implementation of the result type. It's straightforward, but let's not spend time on it. The interesting part is that if we take this get employee supervisor name function from the option example, and I've only changed the type signature. It takes a result and returns a result, but the rest is completely the same. So I've got a new function with a new behavior with exactly the same body. So what's the behavior of this function? It will, if I give it an ID of an employee that has a supervisor and it has a name, then I will get a result with this name. But if anything goes wrong, I will get some error message describing me why I didn't get this name. So just to make sure that you understand it, given this hierarchy of employees, I wrote here some calls of these functions. So first I give it an ID of an employee that has a supervisor, and I get a success with its name. Then I give it an ID of an employee that has no supervisor. So I've got this no supervisor message. And finally, I gave it an ID of an employee that doesn't exist in the repository. And I've got a message saying no employee found. Does it remind you something? What we did is kind of like exceptions in imperative languages. And the result type is actually the exceptions of functional programming. And it's actually better than exceptions because it's more type safe. Because you always have to say when writing a function that it can go wrong and what kind of information you will return in this case. And there is also a very nice concept describing this result type. It's invented by Scott Walshin, and you can read about it under this URL. It's about F#, but it's all the same in JavaScript. It's all about concepts and not programming languages. It's called railway-oriented programming. So there is this metaphor of railways. So the result type is such a railway switch. And if we have a successful operation, then we go the green track. But if something goes wrong, we go the red track. And what flat map is about, it is about taking these two switches and combining them so we get a new set of tracks. And as long as everything goes right, we stay on the green track. But once something goes wrong, we go to the red track and we can never get away from it. All right, so we had options, we had results. Now let's do something completely different. Let's add some asynchrony to our application. Let's think about not empty results, but future results. Results that are not available at the moment, results that will be available in the future. For example, because we have to go to the server side and ask for them. We can use a mechanism that most of you probably know, promises for that. So we change again our interface, employee interface. Now supervisor ID is a promise of number, which means that if you want to know the supervisor of given employee, we have to wait for it. It's not immediately available. We also changed the get function in repository, the get method. It also returns a promise of employee, which again can mean that you have to ask the database or the server side to know what's the employee with given ID. And now, again, the same code that we have used, well, almost the same, that we have used with option result, it still works. It has completely different semantics, but what changed here is that instead of flat map and map, we have then. And that's just the decision of authors of promises, that they have single operation instead of map and flat map. But the whole idea is exactly the same, that you can compose these promises like this. And of course, the semantics of this method is now different. It's not about handling empty results, it's about handling asynchrony. So this function will give us a promise that will only be resolved when all the promises on the way are resolved, right? So it's something different than options, but it's still the same code. And finally, the last example I want to show you are observables. So now we don't have future results, we have observable streams. So we are doing reactive programming, and let's say that the supervisor ID of an employee can change in time, so it can emit different values. So now supervisor ID is an observable of number. And our get method of the repository also returns an observable of employee. So again, it can be either pushed from the server or something like this. So now if we again take the same code, it still works. And it's even better than Promises because it's again flat map and not then, like in Promises. And if you know RxJS, you're probably more familiar with concat map or merge map, but concat map is just an alias for flat map. Flat map is a more traditional name. There is also a different name, bind, and it's like in the old classic functional programming. Okay, but so what was all this about and what all this has to do with monads? So the thing is, all these 4 types I talked about were monads. And what this means is that monad is such an amazing abstraction, it's so broad that it can implement these 4 completely different scenarios, having empty result, having success or failure, asynchrony, and reactive streams. And actually, monads can do much more. For example, an array is a monad. Not in JavaScript, it lacks some operations, but if you use Lodash, for example, it becomes a monad. So the definition of a monad, what all these things had in common was flat map and map. But flat map is the most important thing, also known as bind, as I said. So flat map is the operation that allows you to combine these monads. It can combine monad with reaction to these monads. And it might be very intuitive, might not be intuitive, but that's like an essential thing that allows you to compose software from functions. And you can build very complex stuff from very simple things using monads. Another requirement on monad is that there is a function called return. And it's just a simple thing that allows you to create a monad from a regular value. So in option, we had sum class. We can wrap any value in sum class. In result, we had success. We can wrap any value in success. In promise, we have promise.resolve. We can take any simple value and create a promise from it. And with observables, we have observables.off, which takes any value and returns a stream that emits this single object. And what also monad has to do is to follow a set of monadic laws, and that's the formal part. I don't think it's necessary to understand it, to have the intuition, so I will just skip it. But if you are interested, you can have a look at the monadic laws. So to wrap it up, what are monads? As I said, monads are a great abstraction, a very broad abstraction that you can use to implement many different things. So just imagine that results are like exceptions. For example, options are like strict null checking that was added to TypeScript some time ago. Promises are solved with async await in TypeScript. So normal languages need separate language features to solve these problems. But you can solve all these problems with a single thing, with monads. So that shows how broad abstractions they are. Monads can also be looked at as a programmable semicolon. What I mean by that is, in some languages, you have a special syntax for monads, which allows you to write them with semicolon, which looks completely like an imperative program, but underneath it's all about monads. And the thing is that they allow you to hide some boilerplate. So when we are talking about option, we could abstract away the checking for undefined, right? We could hide it inside the monad, and our code was showing just the business logic. In case of promises, we could hide the callback hell, because that's what promise does. It handles the callback hell for us. It's hidden inside the promise monad. What we do is just write the business logic. Monads promote declarative style. because they allowed us to write our program as a stream of data transformations, just a pipeline of data passing through a single pipeline. So that's very declarative and allows you to write code that's easier to maintain. And finally, when you are working in a type-safe language, monads improve type safety because, for example, when we introduced the option monad, it forced us to mark the get method of employee repository as option, which is more explicit than saying that it just returns an employee, which can be null, can be undefined, it can be anything. Okay, so that was it. I hope you liked monads and I've got you interested in them. As you saw, you might have not known about monads, but most of you are probably using them because I guess most of you are already using observables or promises. And that's why I thought it would be very interesting to talk about them. So that was it. If you would like to learn more, you can visit my blog, Code with Style Info. I have also recently recorded a video course about functional reactive programming in Angular, which is available on YouTube. So that's it. Thank you very much.
You can see there is a question coming from YouTube, so we really have connection with them. Listen, so what happens if you don't handle one of the left error cases? Do you have to handle each case? Can you just silence one kind of error?
I'm not sure I understand. Could you repeat, maybe?
Okay, so what happens if you don't handle one of the left error cases? One of the left is written in semicolons, in quotes. Do you have to handle each case? Can you just silence one kind of error? So this probably means that if you write a monad, is it prepared, or can you somehow filter out some kind of errors you can spot there?
Well, I guess you can have a result has two type arguments. So the first one is the successful case. The second one is the error case. So the error case could be a class, an abstract class that you have many different concrete exceptions of this class. So you could probably filter, you could write a filter operation, like you had map, flat map, you could add filter operation that would work exactly like on arrays, which would allow you to only handle certain kinds of errors. So yeah, maybe that answers the question.
Okay, so that's the way how to handle only certain kind of errors. Any other questions, maybe from the room now? No questions, so next question from YouTube. Łukasz Jagodziński. When using monads, you actually keep every value with extra objects. What about performance and memory usage?
Yeah, that's true. Well, that was very naive implementation of monads. There are a lot of different libraries in the internet that will do that in a more clever way. That would probably reuse the objects on the way. So what I would answer to that is just try to use some monadic library instead of writing the monads by hand.
Okay, and Łukasz Jagodziński also asks, what about error thrown inside monad? Does it catch errors, or you have to catch them by yourself and return failure?
So, like you throw an exception, a regular exception inside the monad, or? Well, yeah, you shouldn't be mixing exceptions with the result monad. Like you can write your result monad in a way that it would catch the exception and transform it to a failure. But in general, exceptions and monads are from different worlds. Exceptions are from imperative world, and the monads are from functional worlds, so you shouldn't be mixing them.
Okay, another questions about functional programming. No questions, so congratulations, Miłosz.
Thank you.